Hey guys, welcome back to another video, and today would be covering other topics of linked list. So the first thing that we would be covering is getting an element into the list. So since linked list does not support random access, we have to scan the list to find the node at the given index and then get the element within that node. So remember I said that linked list does have some pros. However, to give that pros, like not having a fixed length, you are basically sacrificing the support for random access, right? You cannot directly go into the list and say I want the fifth element. You actually have to traverse the whole list to go to the fifth element or the fifth node and get its corresponding elements. So how do we do that? So there are like few things that we need to understand here. So let's say this is the linked list that is given to us, and each has, let's say, some values inside of it. So 1, 2, 3 and 4, right? So now you want to add a new element to that list. Let's say you want to add 5. So you created this new node of yours, right, which doesn't have any links yet. It doesn't have any connections. So this node dot next refers to null, right, for now. And this is the list that you already had, and in this list this was the head and this was the ending of that list. And in the end, like the fourth node here, its dot next refers to nothing, right, null, because this is the end of that list. But now you want to put this after 4. So what do? So the process here is you create that node. So node, let's say node n goes to new node, and in the parameters you pass the element that you want to put inside of it, and you put null for now. So you created the new node, right? Now what you have to do is you have to traverse that linked list that was given to you. So you have to traverse it, go to the end of that list. So in the fourth position you have to go there. Then you have to say that n dot next equals to, let's say we name it m, equals to m. So now what's happening here is that the linked list that we had, so 1, 2, 3 and 4, has a new connection. Like the last node has a new connection which refers to this, which is 5, and 5 doesn't have any next list, right, next nodes, so it doesn't refer to anything. So this is the end of that list. So let's look into the code here. So how do we, like, the thing that we have to remember here is to get to the last node. So what is like the parameter for this, right? And like before we did while n not equal to null, you traverse it, we go through the whole linked list, but at a point n does become null. That means we have reached this spot where we do not have any nodes, right? So how do we do it? We basically do this while n dot next not equal to null. So what this is basically checking is the next node, is it null or not? So let's try to traverse what's happening here. So initially we have this head, and this is how we are going to iterate. So this is the head. We check is head dot next, which is this one, is it null or not? It's not null. We go to this portion. We're going to check if its next node is null or not. It's not. So we go into this one. We're going to check is the next node null or not. It's not. So we increase and we go into this one, which is the last node, right? Then we're going to check is the next node, is it null or not? So for this case it is null. So we would, the loop would like go inside, and n would be basically pointing to the last node in the linked list. Thus we have found our last position or the tail of the list, and then you can easily say like tail.next or whatever variable that you use to get this variable. For our case that was n, so let's use n. So n.next equals to the new node that you created, thus creating or putting the new node into the list. And this is what we have basically done here. Now what if, let's say you want, so this is like the list that is given to you, and let's say you want to put your new node that you have created in between these two. So this, let's say number them 1 2 3 4 and 5. You want to put it between 3 and 5. So let's say the value is 3.5, right? So we want to put it in between 3 and 4. So how do we do it? So this is pretty easy. Like from the previous video, you know how to count the linked list, like count the nodes. So what you do is you basically traverse it. You go here, you increase count by 1. You go here again, you increase count by 2. You go here, you increase count by 3, and there should be a checkpoint because you wanted to put the new node in between 3 and 4, right? So you have to connect it. So how do we connect it? So you check if the count is equal to 3 or not. If it's equal to 3, that means you're at this position, right? Let's say that position, that node is n. And what you do is, this is your new node m. So n dot next, shouldn't this be the new node's next node, right? So if you think about it, it's like this. So this is the node that we were working with, and this is the new node of yours. And this should be the sequence, right, where your new node is in this position, where this is 1 2 3 3.5, this is 4 and 5. So from the previous thing that we saw, right, so 3 had a next node which is 4. So shouldn't 3.5 have that same node, right? Because it sits between 3 and 4. So previously 3 represented, like 3 had a next node of which is 4. Now 3.5 would have a next node which is 4. So how do we do it again? So we reach 3, which we reach this point, and in this point we basically say m dot next, which is your new m is your new node. So m dot next is n dot next. N was 3 and n dot next was 4, right? This one from the previous linked list. Now what is happening is that your new node is representing the older node 4. Like the next node of your new node is 4, and n, which is your node number 3, n dot next is your new node m. So what's happening here? We are basically traversing it. So first node, second node, third node, we came here, we did n dot next, which is n was this one, so n dot next equals to m, which is this one. Then m dot next equals to n dot next. So n had a previous next of 4, so we put 4 in this position, and so on. So this is your 1 2 3 3.5 4 and 5. So this is how you add nodes at the end or at some middle point. So we can see like what I said here in this portion of the code. Here we are basically, we have like functions that define, that is like defined to find that corresponding node of a particular index. So you give the index number and it gives you that corresponding node, right? So public stack, we have created a method that takes the head, which is the head of the node, this one, the size of the elements in the list, and the object element which you want to put inside, so 3.5 in this case, and index, so where you want to put it, so 3 for our case, right? Then you have to check, is the index number valid or not? So let's say if I put -1, that isn't a valid number. So we are basically checking is it a valid number or not. Then after the check is complete, we create our new node, which is node new node equals to new node, and we are putting the element, and initially it doesn't have any links to anything else, right? So then if we check that if the index is 0, that means that the created node that we want, m, we want it to be the head of the list. If it's the head of the list, that's pretty easy, right? So we do m, which is our node, so m dot next equals to the head, and we make head as the new node m, which is done basically here. We are making our new node m the head and putting a link of the previous head, thus making the whole chain. Or else, if that's not the case, we want to put it somewhere in between, right? The first thing that we have to get is the predecessor node first. As I said before, we need to get 3, right? So we need to get the predecessor node. So node pred node at index -1. So for this case, so if you wanted to put inside, let's say 4, right? We wanted to take the position of 4. What this code does is basically the node at function, it returns the node at the 3 number position. So basically finding you this one, and then new node dot next is pred dot next, which we talked about here, right? So m dot next equals to n dot next, n being the previous node, and pred dot next equals to new node. So this points out to the next node, and your new node points to or the next of the previous node. I know it's a bit confusing. The best thing here is to try to go through the theory first and write things down on what's actually happening here, then try to look into the code and try to write it on your own. Linked lists are very easy and very helpful in almost all the programming courses that you'll be doing, and it would be very beneficial if you are applying for a job somewhere. They're definitely going to ask you about linked lists, so do it like that and it would be okay. And finally, we would be covering removing elements. So how do you remove elements? So there can be 2 cases where you can either remove the head or you can remove a certain element from the list, right? So this is the list that you have. Let's say 1 2 3 4 and 5. You want to remove 3, right? So for the first case where you want to remove the head, that's pretty easy, right? From the picture you can see that you can remove this and make this the new head. So how do we do that? We basically do this. We make head equals to previous head dot next. So what is this doing? This is basically saying head dot next, which is 2, is the new head, nothing else. And how about if we want to remove a node that's in the middle, right? Let's say 3. So how do we do that? So for this case, we need to definitely know this one and know this one, right, to connect them, because if we remove 3, we need to connect 2 and 4. So how do we do that? So for this case, we basically need to know this node and this node. So we need to know 2. So let's say 2 dot next would be equal to 3 dot next, and we're done. So then what's happening here? 2 is basically pointing to 4 rather than pointing to 3. So 3 doesn't have any connections anymore, thus 3 is gone. So what are we doing in this case? So you did understand the concept of how we remove the head. This is the code for it, to removing head, and this is the code for removing something in the middle. So we get the predecessor node first. So for our case, that's 2, we get 2 first, so the pred contains basically the second node, then removed node equals to pred.next. So pred.next represents node number 3, which we want to remove. Then pred.next, which is 2. 2.next was what? 3, right? So it's 2.next would be basically removed node. Removed node is what? 3, right? So is basically 3.next. So what is happening here? So it's basically 2 is directly pointing to 4, and 3 doesn't have any connections anymore. And this is basically helping the garbage collector. It's up to you if you want to do it or not. So this is how linked lists work. This is how removing linked lists works. Hope you guys did understand something from it, and hope I was a little bit of help here. If you have any comments or suggestions or anything that you think that helped me make better videos, do let me know, and please do subscribe. Thank you.